Good day, dear panels. My name is Danoshini and today I will be presenting on my final year project entitled Statistical Analysis of Stone Mastic Asphalt Incorporating Knaf Fiber. I will now begin my presentation. Stone mastic asphalt consists of two sections as in coarse aggregate and bitumen-filled mortar such as bituminous blend, filler and stabilizing additives. Stone mastic asphalt is usually used as a binder course and used for heavily axial-loaded roads. Well, compared to the normal thick-graded asphalt, stone mastic asphalt provides excellent skid resistance due to its rough texture characteristics. In this study, a statistical analysis was performed using data from resilient modulus tests, dynamic creep tests, and abrasion loss tests. Also, knaf fiber will be used as the natural fiber incorporated into the stone mastic asphalt since its potential has been very well recognized as a cellulose material with environmental and political advantages. The problem statement of this research has been one of the most significant criteria when constructing the flexible road, which is permanent deformation, specifically known as rutting, which is also induced by fatigue. In order to reduce such issues, this study shall now intend to promote knaf fiber incorporated stone mastic asphalt. The objectives of my research are to develop a regression model of stone mastic asphalt incorporating knaf fiber and also to evaluate the mechanical performance of stone mastic asphalt incorporating knaf fiber. The procedure for this research requires the usage of Minitab 19 for the statistical analysis. The proportions of knaf fiber used in this mix are 0%, 0.2%, 0.3%, 0.4%, 0.5%, and 0.6%. The overall process of developing these models consists of descriptive statistics, correlation analysis, linear regression model, normality tests, and also the PAT-T test. All specifications for this research is in accordance to the Malaysian Public Works Department for Roadworks and also ASTO. The significance of this study is to improve the mechanical performance of stone mastic asphalt, to contribute as a solution to the issue of permanent deformation, and also to act as a reference for the future. I based my study on few studies as shown in this slide. The first one is performance of stone mastic asphalt mix using selected fibers. This study uses knaf fiber and the results indicated that natural fiber can efficiently retain the binder in the mix. The next study, entitled Abrasion Loss and Binder Drain Down of Porous Asphalt with Nanosilica Modified Binder, proved that the existence of nanosilica is capable to enhance the properties of asphalt binder. The next study, entitled Evaluating Mechanical Properties of Stone Mastic Asphalt Modified with Ferric Oxide, proved that the strength of the asphalt against rutting has improved. The next study revolves around modified asphalt mixtures, which indicated that addition of percentages of additives increased the rutting resistance. The final study showed on this slide revolves on the behavior of stone mastic asphalt mixtures, and the results revealed a better performance. Now I will be explaining on the methodology done throughout my research. Firstly, I keyed in the data into Minitab 19. Then I ran a few analyses. The first one is descriptive statistics. It is used to summarize a set of observations to describe the basic features of data in this study. Next was the correlation analysis, which is a statistical method used to evaluate the strength of relationship between quantitative variables. Then the regression analysis was done to develop a model to predict the values of a numerical variable. Then the normality test is done to determine whether the assumption of normality of sample is valid so that the test will be reliable. Finally, the PAT-T test analysis is done to determine if there is a significant population mean difference. The expected outcome from this research is to develop a regression model of stone mastic asphalt incorporating knaf fiber to also improve the mechanical properties of stone mastic asphalt and to act as a solution to the problem statement. This is the Gantt chart of my progress throughout my research study. Now I will be explaining on the results obtained. There were two models developed in this project. The first model relates the resilient modulus to the temperature of the test, which was at 25 degrees Celsius and 40 degrees Celsius, percentages of knaf fiber, which was in the range of 0, 0.2, 0.3, 0.4, 0.5, and 0.6%, and the number of revolutions from the abrasion loss and also the accumulated strain from the dynamic creep test. There were 2 trials made under the first model. As to make the difference, it would make to dismiss the parameters which does not affect the results in the first trial of Model 1. As said, the second trial was made by dismissing the accumulated strain as it does not affect the dependent variable, which is the resilient modulus. An overview of the collected data can be summarized in descriptive statistics, which contain all variables information such as value of mean, median, minimum, maximum value, skewness, kurtosis, standard deviation. From the information provided by descriptive statistics, extreme values can be detected during screening process. Correlation analysis is the procedure applied to identify the possible relationship between the dependent and independent variables, which will be used later to develop a regression model. All possible variable combinations were analyzed using correlation analysis, and the result for overall variables is shown in the correlation matrix in tables on the slide. Each column denotes both Pearson correlation value and p-value, where Pearson correlation value is presented at top and the p-value is presented at the bottom row. The first model of linear regressions was carried out with the resilient modulus of stone mastic asphalt mixture as the response, while temperature, percentage of kanaf fiber, number of revolutions, and accumulated stains were the predictors. Figure on the slide lists the values of the constant and the 4 predictors, whereas the other figure below shows the value of variable with the other 3 predictors. The equations show that the coefficient for all important variables for this model had a positive sign, implying that an increment of all independent variables would lead to an increment value to the resilient modulus, except for the accumulated strain value. Therefore, a second trial was made by dismissing the presence, and the results are shown in regression equation of the second trial as shown. In addition, R-square is one of the criteria that is used to determine whether a linear relationship between the response and the predictor fits the data well. From the figures of the model summary, the variables used for the model were 78.33% for the first trial and 73.46% for the second trial of the variations. According to the figures, certain variables for the resilient modulus model were significant independent variables for predicting resilient modulus, where the p-value of the linear regression was less than 0.05, which means the null hypothesis, which says that the predictor cannot be used for predicting this model, was rejected, and therefore the alternative hypothesis was accepted. Hence, certain predictors can be included in the model for predicting the resilient modulus. Based on the figures provided for the analysis of variance, both trials showed that the p-value is less than the alpha level of 0.05, hence the regression model was significant and thus could be used to explain or predict the resilient modulus. A normality test is used to determine whether sample data has been drawn from a normally distributed population. If the assumption of the normality is not valid, the results of the test will be unreliable. Normality test is evaluated using Kolmogorov-Smirnov test, where the p-value should be more than 0.05 to indicate the normality of the developed model. The probability plot showed that the p-value was more than 0.05 as it was 0.118 and eventually passed the requirement. The skewness for a normal distribution is 0 or should have a skewness near 0. Figure containing the statistics on the slide represents the skewness value for resilient modulus, which is negative 1.24, while kurtosis value is 2.63, which is close to 0, which means the data can be accepted for the model development. The pan-t-test indicated that the p-value is lesser than 0.05, which means sufficient evidence to reject the null hypothesis as 5% level of significance. This indicates that the resilient modulus predicted model differs much from the resilient model's empirical values. Now I will explain about the second regression model. The second model was initiated by accumulated strain as a dependent variable. There were also 2 trials made under this model. The second trial of the second model was made by dismissing the temperature of the test. As before, this slide shows the descriptive statistics from which extreme values can be detected during screening process. All possible variable combinations were analyzed using correlation analysis, and the result for overall variables is shown in the correlation matrix in tables on the slide. As analyzed in trial 1 of model 2, the temperature has shown no effect as a variable, and therefore data for temperature was dismissed in the second trial of model 2. The second model of linear regressions was carried out with the accumulated strain as the response, while temperature, percentage of canal fiber, and number of revolutions were the predictors. The first trial lists the value of the variable and the three predictors, whereas the second trial lists the value of the variable with the other two predictors, as temperature was dismissed since it did not affect the response. The equations for both trials showed that the coefficient for all important variables for this second model had a positive sign, implying that an increment of all independent variables would lead to an increment value of the accumulated strain, except for the temperature value. Therefore, a second trial was made by dismissing the presence of temperature, and the results are shown in the regression equation of the second trial. R-square is one of the criteria that is used to determine whether a linear relationship between the response and the predictor fits the data well. From the figures of the model summary, unfortunately, the variables used for the model were 4.17% for both trials, which is far from 100%. Therefore, the linear relationship between the response and the predictor doesn't fit the data well. Based on the analysis of variance, it shows that the p-value is more than the alpha level of 0.05. Hence, the regression model is not significant and thus could not be used to explain or predict the accumulated strain model. The normality test showed that the p-value is more than 0.05, has indicated the normality of developed model. After data transformation process dismissing temperature, the p-value was still at 0.118 and no changes were to be seen. Figure of the statistic represents the skewness value for accumulated strain model is 0.11, while kurtosis value is negative 1.88, which is close to 0, which means the data can be accepted for model development but has to be altered due to the inability to produce a successful linear regression model. The paired t-test showed that the p-value is lesser than 0.05. This indicates that the accumulated strain predictor model differs much from the accumulated strain empirical values. The study concluded that the usage of canal fiber as an additive in stone mastic asphalt has showed positive results in the enhancement of stone mastic asphalt mechanical properties. A high correlation was predicted from Model 1 of the study, since the variables have a very strong relationship with each other. The analysis of variance in Model 1 showed that the p-value is less than the alpha level of 0.05, hence the regression model was significant and thus could be used to explain or predict the resilient modulus model. The regression equations showed that the coefficient for all important variables for Model 1 had a positive sign, implying that an increment of all independent variables would lead to an increment value of the resilient modulus. And last but not least, a successful regression model of stone mastic asphalt incorporating canal fiber was developed. Thank you.